So I have a folder created for diabetes prediction, and also if I check in this directory, so basically we have diabetes.csv. Okay, so let us look at it, what exactly it is and how exactly like what kind of data exactly it has, and we'll feed in the same data to the machine learning models and do. Okay, so here we'll be coding in Jupyter notebooks. Okay, so in this directory I'll be launching Jupyter notebook. Okay, so basically I'll be creating a notebook over here. Okay, there was a typo. Okay, so here we have diabetes.csv. You can open and see. So we have whole lot of features over here. So first thing is like pregnancies, glucose level. What is the glucose level in units? Blood pressure, skin thickness, insulin, body mass index, okay, BMI, diabetes, pedigree functions, and also what are their age and outcomes. Okay, so these are actually supervised learning. So here the outcome, whether it is diabetes or non-diabetes. Okay, so these are the few things which are the kind of features. Okay, so now let us create a new Python file, and also we can name them as diabetes prediction. Okay, so that is done. So now let us get started with respect to the coding. Okay, so here first thing is we need to import the data set itself. Okay, so let us before importing data set, we can import libraries. Okay, so what are the libraries which we will be seeing? We are gonna be seeing a few number of ones. Okay, so first thing is to import a data set. We need pandas library. So I'll import that as PD, and any for numeric operations we generally use NumPy. Okay, for visualization purpose, we'll be importing Seaborn for heat map and also Matplotlib for plotting the graphs itself. Okay, so Seaborn as SNS and import matplotlib dot pyplot as PLT. Okay, and also we'll make the matplotlib inline. Okay, so if you don't have any of these installed, you can just go and do pip install. So by default, every ones are installed except Cburn. So Cburn also Cborn is also pre-installed in few of the packages. Else you can just directly do open command terminal and run pip install. So that will help you out directly. Okay. So now let us import our data set. Okay. So the diabetes.csv file into our package. Sorry, into our Python file itself. Okay. So for that, let us create a pandas data frame with respect to a name of data set itself. Okay, so data set is equal to pandas dot read CSV. Okay, so read CSV. So basically here it is reading comma separated value. So here we have comma separated value folder itself. Okay, so sometimes you will be having tab separated. So at that scenario, need not to worry. You can use CSV itself, but you can give the separator as a tab. Okay, so it will come something like this. Okay, so if you have this option, it is converted directly into tab. So just read documentation for any other information which is required. Okay, so you can see here there is a number of this one. So separator by default there is actually no default, but since the name already suggested it is comma separated, so default case is comma separated for the separate this one. Okay, and also you can do a few of the encodings, whether you want something like that, or encoding errors. So all these are the few of the arguments which you can be using for iterators and all. Okay, so just go through this so you will have a better understanding what exactly this it is capable of. Okay, so now let us go ahead and import our diabetes.csv. Okay, so I should have in the same folder, so that's why I don't need to give any path of the actual file. Okay, so basically here also I'm using path, something known as a relative path. Okay, so this is in relation with respect to my Python file. Okay, so it is at the same location itself. You can see in the same folder itself. So diabetes, so directly it is addressing to this file by just giving its file name itself. Okay, so this is called as a relative path. Okay, so here we are actually importing data set. And also view at that too. Okay, so let me just run that. So here we can see we have the data set. Okay, so we have data like 768 rows into columns. Okay, so these are the few things. And coming to features, we have some pregnancies, glucose, blood pressure, skin thickness, insulin, BMI. So all those which we have seen over here. Okay, so same thing has been imported. Okay, so let us look more about this. Okay, so especially for any missing values or anything. Okay, so for that we can directly do dataset dot. Actually, there are a number of features over here. So here you can see it has my pure Python inbuilt itself. So here I am interested in checking out the info of it. Okay. So if you run that, you will get all the information. So basically, what is the range and the indexes. Okay. So the index is starting from zero. Okay, not this one. So index is starting from zero and ending at 767. Okay. So that is the range what is given, and there are actually nine columns. Okay, so 0 to 8, and you can see actually we have only 768 and everything is non-null. Okay, so basically we don't have any missing data over here. Okay, so even that can be actually manually checked too. Okay, so that is one of the things which we need to do when we are doing exploratory data analysis. Okay, so for that we can actually check whether is null or not. Okay, so is null. So for this, if we give actually is null, it will just print out false and true based on the table. Okay. So here again, the table is not that efficient. Okay. So hence we can sum up all the trues and false. Okay. So false value will have 0 and true value will have 1. So you can see every single row we have no null characters. So that means no empty characters. So this is required when you're doing real-time data mining. Okay, so when data is real-time mined and given to a machine learning model which is already like developed. Okay, so it is already been trained and deployed for real-time applications. So at that scenarios, you might have some data like this. So every time we need to check whether the data is null or not. Okay, and also we can check about its descriptive statistics. Okay, so we don't need to calculate any mean or anything manually. So by just using data set dot describe, we will be getting all the descriptive statistics. Okay, so you can go ahead and check this documentation too, very helpful one. So basically it will generate all the descriptive statistics for us. Okay, so based on this we can actually go and fill out a few of the null characters too. Like for example, we can fill out mean values, we can fill out variance median values and all. Okay, so here we have mean, standard deviation, uh, also like 25%, 50%, 75%, and maximum how much it is. Okay, so those are the descriptive statistics what we can see over here. So basically how many counts we have throughout 768 counts itself, and these are the mean outcomes. Okay, so where I am not much interested of those because I will let my system to analyze. So basically I want my machine learning model or the algorithm to come up with its own kind of understanding with these data, and finally it needs to tell the outcome. Okay, so I think this is mean and median, just ignore them. But mainly with respect to either it will be 1 or 0. Okay, so those are the things which are outcomes. So that is our label of the data set itself. Okay. So let us go ahead do exploratory data analysis on this. Okay, so we can actually check correlationship between two or more variables. So finding important features, cleaning the data before we go on to the modeling. Okay, so which will be helping our model. Okay, so for that, first thing is what I want to do is uh, we'll check out with respect to the correlation. Okay, so basically correlation plot by using heat map. Okay, so let us do that. Correlation plot of independent variables. Okay, so here we can create a plot size. So I'll give plot figure with a figure size. Use feel free to how much ever you want. I'll just give 10 by 8. Okay, and now we can actually create a heat map. We have imported Seaborn with SNS. So SNS dot heat map. Again, heat map has n number of attributes over here or arguments which you can pass on like v in, v out, all those things. So basically, I am more interested with respect to colors. Giving a not, so that is like the boolean or rectangle data set. Okay, so this is optional, but we'll make it as true so that we can write data to each value. So, okay, so if we don't give this, it will be just the color mapping where values won't be displayed. Okay, so that is required. And also yeah, string fmt. So basically we'll give what how many digits we need after the values. Okay, so here we can see there is actually 5 or 6. Okay, so we can restrict to three significant bits in floating. Okay, and also we'll be using cmap. Okay, so cmap, it is basically used for coloring. Okay, so we'll be passing in the colors. Okay, so matplotlib color map. Okay, so here we can just list of what are the colors which we are looking at. Okay, so I'll be doing yellow, green, blue. Okay, so these three things. Okay, so let us go ahead and do that. So first thing is we need to send the data set. Okay, so but I here I'm interested in correlation between them. Okay, so data set dot correlation. So yeah, that also can be evaluated by using just CORR. Okay, so correlation. Okay, so that will be our data which is going with respect to the heat map. And not, so a not is basically telling put down my values on the graph. Okay, so wherever the blocks is there that I need to give. And coming to significant figures, so basically as I was telling, we'll take 3 bits floating point. Okay, and finally cmap the color coding. We'll use yellow, green, blue. Okay, just refer documentation. Now we'll plot it. Okay, so we can plot title as correlation heat map. Okay, so that is executed. Now we can see actually what are its correlationship. Okay, so definitely from pregnancy to pregnancy it will be one itself. So diagonal elements will have correlation of one itself, but you can see the other things. Okay, so here we can see quite a lot of outliers and all. Okay, so the observation shows that all these are actually closer to the outcomes. Okay, so basically uh, not that far away with respect to other this ones. Okay, so they are actually quite closer. Okay, so it is like in this range. Okay, so glucose is one which is little outside. Okay, so you can actually illustrate in different aspects also. You can go ahead and draw many other shapes. Okay, so what they are, and also click plotting density ones also. So I think we shall do that. Okay, so let us explore individual target variables. Okay, so I think can start off with pregnancy. Okay, so exploring pregnancy and target variables. Okay, so I'll have the same plot size. And now we can start plotting over here. So what I'll be plotting is I'll be plotting a density based graph for the pregnancy and the target variables. Okay, so basically we'll be plotting KD. Okay, so plotting density function graph of the pregnancies. If I have a typo, just ignore that. And target variables. Okay, so let us do that. So basically I'll be doing a KDE plot. So that will be sns dot KDE plot, where I need to send in my data set of only pregnancies. Okay, so basically pregnancies and the outcome. Okay, so basically pregnancies, I should probably should not have a typo over here, so I'll just copy paste that, and it should be having the outcome where it is one. Okay, so those two conditions are required. Okay, so here we'll be having data set of outcome being one. Okay, so we are not interested with respect to non-diabetes or the condition where it is non-diabetic. Okay, so when it is one, and also we can actually give some kind of colors, like primary color we can use like blue or red. Okay, and also you can give shade. Okay, so that we'll have a better visualization. Okay, and again we can give KDE plot data itself. Okay, so basically KDSNS plot data outcome. Like again, we have created for one, right? We can do the same for the zero also. Okay, so let me just get the same, or maybe you can give a different naming like this. Okay, so it doesn't matter. We can stick it with one. We are actually having on the same KDE plot itself. Okay, so here the outcome should be zero. Okay, so in the back end, I'll give as blue. Okay, so that's to differentiate between one color and the other color. Okay, so rest all remains the same. So here we can give actually KDE title, X label, Y label, and all. Okay, so basically I'll give set X label. Okay, hope I don't have a typo over here. Okay, if at all it starts complaining, no need to worry. Pregnancies, and also KD Y label, set Y label, density. And we can actually put on the legends also, so that we'll understand what are the positive results and negative results. So that means whichever is plus, it will be positive results, and negative is like zero is negative results. Okay, so positive means diabetes is detected, and negative means it isn't. Okay, so first we are plotting with one, so basically that is positive. Okay, so we can plot that as positive followed by negative. Okay, so let us execute that. Yes, as I mentioned, we have a typo over here. Label. Okay, so here we can see the data. Okay, so according to the data, like this is considered only in terms of women. Okay, so women having diabetes has who have given birth to healthy infants. Okay, so however, the risk of future complications can be decreased by managing diabetes. Okay, so here you can see pregnancy women are quite like kind of going towards positive. Okay, so the risk of pregnancy issues, like it has actually many things. Okay, so like hypertension, depression, birth abnormalities, and so on. Okay, so these are actually increases the diabetes effect too. Okay, so that's why we can see diabetes in the case of women. Okay, so similarly we can explore the glucose one also. Exploring, I'll just copy few of the things over here, and we'll also see the target variable, that is nothing but our outcome itself. Okay, so let us maintain the same graph, same size of the graph. Okay, and coming to this one, we shall do a Violin plot. Okay, so we can understand where exactly it is sitting in between. Okay, so for that we'll be using SNS Violin plot. Here data will be equal to data set, and the column which we are looking at on x-axis we'll put as outcome, and y would be nothing but our glucose. Okay, so I just want to check with respect to glucose. Remember it is capital G over here, and we can actually split it. Okay, so we can just enable the split as true. Okay, so what else are the arguments you can pass in? Okay, maybe we can give line width. Okay, so what will be width of the line? So line width is over here. So line width, I think we can give 2 units. And we need to have an inner fitting light. So okay, so inner basically we can give box, quarter light, point, stick. Okay, so we'll stick with quart. Okay, so quartile or quart you can use. Okay, so we'll use that just for visualization purpose over here. Okay, so you can see this is the glucose. So this is like kind of likely to level up. Okay, so basically the outcome whenever it is reaching after a certain level, it is having majority. Okay, so until this point, maybe around this region, some are having diabetes, some doesn't, because other factors are also affecting. Okay, so it is not with respect to a single factors over here. So there are multiple other factors, right? So glucose level, so you can see as it rises, so definitely there is huge margin of glucose level. Okay, so that's how it is. We can actually create a density plot also instead of violin. Okay, so uh, we can go and do that. Okay, so I'll just fetch this density plot and we can modify the same. Okay, so here I'm going to do glucose, and then I need to change few of these things. Okay, so basically glucose, so the comment also I'll change. Same goes for here. We can just copy paste these over here. Okay, so I think that should be enough. We don't need to do anything else. Okay, so here also you can see most likely after reaching a value somewhere around 125, it is a kind of peak. Okay, so after somewhere around 100 itself, we can tell majority of the people are having a positive this result. Okay, so that is the few of the exploratory data analysis. So we can see that, and yeah, we don't have much of outliers. Okay, so if you want, we can go ahead and check that too. Okay. So now let us get with respect to few of the things. Okay. So one thing what I would like to change is, so here coming back to the data. So here I want to replace any of the zeros. Okay. So basically glucose, any of the zeros with respect to a median value. Okay. So same goes for blood pressure, BMI, and skin thickness. I think we can do that also. We can replace that with respect to the mean value. Okay, so instead of median we can use mean value, and also for insulin too. Okay, so here also we have insulin like value 0 0 0. Okay, so here it is kind of outlier for this one. Okay, so we didn't visualize that. So if you visualize that, basically we'll have a whole lot of different outliers. Okay, so for that, replacing with respect to mean values will ease the machine learning algorithms to understand it much better. Okay, so let us go ahead and do that. So here we'll replace a few of these zeros. Okay, so replacing zero values with the mean or median of the respective feature. Okay, so we are not going to put a different mean to a different this one. Okay, so first thing is we'll create for glucose. Okay, so data set will have uh, glucose, which has to replace with its mean values. Okay, so what we'll do is data set glucose column. Here we are gonna replace, what are we going to replace? We are gonna replace 0 with, again, mean value of data set of glucose. Okay, so you can actually create different variables above this also. So you can evaluate mean value of glucose and then come and use the same value over here. Okay, so instead I'm just doing implicit itself over here. So I think we'll do median value for this. Okay, so it has been optimized. So median is the best fit over here. Okay, so that is done for glucose. So we can do similar things for others. Okay, so basically I'll just copy this and make changes. So after glucose, I think we can do for blood pressure. Actually, blood pressure should not be 0. Okay, so just in case if it is there, or maybe some kind of data is missing or anything. Okay, so we'll do that also, and then we can do the same. Maybe I'll copy this glucose, or we'll do for next feature, which is BMI. Okay, we'll do BMI. It doesn't matter which order you do, but ultimately it is fine. BMI, I forgot to replace blood pressure over here. So BMI. Okay, so here we'll be taking mean value, not median. Okay, so let's get that. So similarly, I think two more: thickness, skin thickness, and insulin. Okay, so skin thickness. Okay, let us go ahead and execute that, and now we can actually check what exactly is our data set. Okay, so basically it looks similar, same things okay. So but wherever you notice we had values like zeros. Okay, so especially in insulin, so they have given with respect to average values. So why exactly this insulin is 0 is like basically these are from external factors, but internally it will have some kind of certain amount of insulin which is required for maintainability of the body. Okay, so that is the way how we have done. Okay, so that is done. I don't think so anything furthermore is required, and only thing is to create our dependent and independent variables. Okay, so let us go ahead and do that. Okay, so basically here we are going to take all these uh, as our features, and the outcome would be nothing but our results. Okay, so basically the labels or the dependent variable. Okay, so let us split that. Splitting independent variables or features, both means one and the same. Okay, so here will be x for our independent ones. Okay, so data set, I just want to drop out one of the features which is nothing but outcome. Okay, so that is our y. Okay, so that will be output, and I will give access as 1. Okay, and y would be nothing but our outcomes. So data set of just outcome. Okay, you can execute that. Now you can go ahead and check what is x, what is y. Okay, output does not have on this one. Okay, I have not told what exactly it is. Yeah, I have done drop of data set. I have defined now. So by default access is 0. Basically 0 is like an index or a column. Okay, so I just want to drop down the entire column itself. So output. Okay, so my bad. So it is actually outcome. So let us re-execute that, and now we can see x. We can see same thing except we don't have the outcome, whereas outcome is inside y. So this will be our outcome. Okay. So that is our data is ready now for training of any machine learning algorithms. Okay, so we'll start off with first thing is we'll start off creating the test data set and training data set. Okay, so we need to have a part of data set for validation or testing purpose. Okay, so it won't be majority, but a bit. Okay, so let us do that. So we'll be splitting the data set into training and testing data sets. Okay, so for this we have an feature directly. Okay, so where you can actually randomize and shuffle and split it up also. Okay, so that feature is known as train test split from sklearn. Okay, so we shall implement that. So if you don't have sklearn, just do pip install, you will have that. Model selection, import train test split. Okay, so this is the function. We can execute it, and then let us check what exactly train test split is. So basically, it will return in a format of xtrain, x test, y train, and y test. Okay, so here we can see an example how exactly it will be returning. Okay, so this is the format which we will also be using. Okay, so let me just fetch this itself. I'll copy paste this over here and get rid of this extra stuff. Okay, so x, y we are passing in, and test size maybe we can keep it for 33% itself. So basically test size we are keeping 33% aside, and 67% of the data set is given for training purpose. And random state, basically you can actually give a random value which actually randomizes the this one. Okay, so basically it jumbles up. Okay, so these features will be toggled around. Okay, so you can see that also. So just give a number. So control the shuffling apply to the applying of the split. Okay. So let us execute that. Now we can actually go and check what exactly is our extrain, this one and all. So you can see it is randomized. So you can see index is jumbled up, and also it has only 67% of the total 767. Okay. So if we do that, if you do the math, you will arrive at 514. Okay, so same things goes to our X test, Y train, and Y test. So feel free to check out what are those values. Okay, so now I'm more interested in creating the model itself. Okay, so making the model. So first we'll start off with KNN. Okay, so let me import that from sklearn. So it is actually having KNN is nothing but k nearest neighbors. So we have under the hierarchy of neighbors. Okay, so import k near neighbors classifier. Okay, so that is the class neighbors classifier. I can execute that. Okay, so that no typo. So that is done. Now let us create few of the lists. Okay, so basically we'll loop around for this. So here k nearest neighbors we need to predefine and tell I wanna have two neighbors, three neighbors, four neighbors, like that. Okay, so at this moment I'm not sure which is the number of neighbors we need. Okay, so what we'll do is we'll evaluate in the range of having 1 to 10. Okay, so we'll have a for loop for, I'll call it as n neighbors. Okay, so n neighbors in range 1 comma 11. Okay, so basically starting with 11 and ending with 10. Okay, so here basically I forgot to mention two different empty lists. So basically I want to have accuracies. Okay, so training accuracy and test accuracy to be stored for each this one. Okay, each number of neighbors. So I'll create empty list which will be appending inside the loop. Test accuracy. I think I have a typo. Okay, so that is done. So first thing is what we need to do is we need to build our model. Okay, so we'll call our model as KNN. KNN will be nothing but K neighbor classifier, and I need to pass in n neighbors. Okay, so n neighbors I need to give as n neighbors itself, because I am looping around over the same parameter over here. Okay, so at the first loop it will be 1, then it will go 2, 3, 4 and all. Okay, so during when it is 1, next is fitting in our training data sets, so that is xtrain and the dependent variables which are ytrain. Okay, xtrain and ytrain. Now we can actually check the scores of it. Okay, so check accuracy score. So the accuracy score will be appending it to training accuracy and test accuracy. So training accuracy dot append. What will be appending is KNN score with respect to our uh, xtrain and ytrain. This is our training accuracy. Okay, and similarly for our test accuracy, append KNN score will just pass in our test data set. Okay, so x test and y test. So we can go ahead and execute that. Okay, so now actually you can just see these results. Okay, so basically you can just check what exactly they are, but rather I would like to visualize it. Okay, so we'll just use a simple plot function from matplotlib with respect to the range. Okay, so the range is nothing but range of 1 comma 11. Okay, so that is our range which is varying, and I want to plot training accuracy score, and here I can give the label as same thing itself, training accuracy. Okay, so similarly I want to create for test accuracy. So test accuracy, I might have typos, we'll see later, and we can give plot labels, x label, y label. Okay, so basically we'll have accuracy in our y label, y axis. So this is y, this is x, and here we'll have in neighbors, in neighbors. Just get this. Okay, and also we'll just to be sure we'll add legends, because here we are not giving any color mapping, it will automatically take. So here I have a typo. Okay, so here it is showing only training accuracy. Why not test accuracy? Only test accuracy, not training accuracy. Okay, I replaced in both places. My bad, I don't know why I did that. Okay, okay, so let us execute again. So now you can see the training accuracy definitely at the first initial. It is like when you have one neighbor, so basically it is like 100%. It does everything, but there is a longer run. Okay, but whereas test accuracy, you can see it is very less. Okay, so this is getting improved and so on. Okay, so I think the best one what we can tell you is the maximum for test accuracy is somewhere around 10. Okay, so 9 and 10 are in the similar pace. Okay, so we can consider that as our test accuracy. Again, based on different this ones also you can have different kind of figures. So but usually 9 or 10th iteratives will have the best neighbors. Okay, so that is why what we'll do is we'll consider only 9 neighbors. Okay, so we'll just copy paste this again, we'll make this as 9 neighbors, or even according to this present graph we can do as 10. Okay, so we will take that and we'll fit in our x train and y train. Okay, and if you want you can go ahead and print accuracy score. Okay, so basically uh, the same thing over here which we have done. So printing this, you can mention what exactly it is also. Okay, so you can mention like training accuracy. I will just do something like this. Next is nothing but our test accuracy. Okay, so test accuracy We need to get in X test and Y test. Let us execute that. So basically here it is telling a whole lot of value. So you can do a format and tell only 2 digits or 3 digits. Okay. So basically here we have 78.79% when it comes to our training accuracy and test accuracy somewhere around 72%. Okay. So I think that holds true with respect to just referring this graph itself. Okay. So feel free to do more number of neighbors and check whether the accuracy is increasing or decreasing. Okay, so there will be at some point where it might meet also. Okay, so both are being at the same level. Okay, so I think having around 72% accuracy is kind of pretty good for uh, pretty good for a machine learning model. Okay, so let us try out few more this one. Okay, so we can see whether it performs better or not. Okay, so now let us see for decision tree classifiers. Okay, so basically let me import that from sklearn tree, import decision tree classifier. Okay, so not recursive. So tree I'll just call as T tree or DT. So both any this one can be done. So decision tree classifier, and I can think I can we can give any kind of random state. Okay, random state as 0. Okay, so you can actually go and check what exactly it is in the package. Okay, so I'll fit in with respect to my X train and Y train. Okay, so I have here only. So I think I can do the same thing over here. I can print out the same things instead of KNN, it will be DT, device tree. Okay, so basically training accuracy is pretty good, 100%. But whereas test accuracy is around 68. Okay, so a bit lesser than what we can expect from this one. Okay, actually we can actually increase the depth of the decision tree. Okay, so we can tinker around with respect to decision tree that has few of the other this one also. Okay, so here maximum depth nothing is given over here. Okay, so basically we can give that as 3 and we can check whether it is working well enough for us or not. Okay, so what I'll do is I'll do this again with just a newer one. Okay, so I'll just give us DT1, DT2, something like that, device T1, just a different naming over here. Okay, but here as I was mentioning, I want to give more depth. Okay, maximum depth. You can do some 3 nodes. Okay, so even 3 deep cells it can go down. Okay, so let us see whether the accuracy is affecting. Yes, definitely. We can see actually training accuracy has come down, so that is not at all a bad thing, because here if you are not giving depth tree, it is on the top lowest level, right? So it will be predicting with 100% accuracy, but test accuracy has slightly gone up. Okay, so from 68% to 69%. Okay, so that is a good sign. Okay, so now let us do one of the other classifiers. Okay, so basically we have something known as MLP classifiers. Okay, so MLP is multi-layer perceptrons. Okay, so by the name itself, it tells like it connects like a neural network. Okay, so it is unlike it is not actually similar to support vector or naive based classifier. MLP relies on underlying network, neural network to perform the classifications. Okay, so that is a info about MLB classifiers. So it is in neural network. So let us import that from sklearn dot neural. There are a whole lot of algorithms coming up day by day. Network import MLP classifier. Okay, did I make any typo? Ah, okay. Sometimes it doesn't auto correct, auto detect. Okay, so basically I'll be creating something like this itself. Okay, so here instead of this I can give MLP in short, and MLP classifier, and random state. Maybe we'll go with some other random number like 42. Okay, and next MLP dot fit with respect to our training and test data set. Sorry, training data sets. Okay, and we can predict same training results and test results. Okay, for our MLP. Okay, so here let me give us MLP. excuse me. So basically here also we have some kind of similar results. Okay, so 68% accuracy. Okay, but here we are actually not having another step which is like kind of standard scaler. Okay, so if at all we scale out our data. Okay, so if we create in standard scaler, let us see whether it increases any accuracy further or not. Okay, so let me import the pre-processing step known as sklearn pre-processing, import standard scaler. Okay, so I'll create SC as my object for standard scaler. Okay, so I'll create my new variables for extrain and ytrain. Okay, so extrain scaled data. Okay, so SC dot fit and transform. I'll do both for extrain, and similarly I need for x test. Sorry, x test also. Yeah, I don't need to do any scaling for our results, right? The outcome that would be logical. Okay, so let us execute that. So that is done. So now what I'll do is I'll do the same thing again over here with respect to I'll give as MLP1, MLP1. So instead of extrain, I'll get extrain scaled data and xtest scaled data, and also here train scaled data. Okay, so let us execute that. So now actually it is like kind of a drop in accuracy. Okay, so um, okay, that did not help us over here. So maybe we'll change the random state, maybe 0 or something like that. Okay, so still it is having a similar effect over here. Okay, so in this way we can actually check many things, and also I am having some kind of error over here. Stochastic optimizer. Okay, iterations it is having more. Okay, so a bit of a limitation for me over here with respect to my neural network perspectives. Okay, so basically as I mentioned, your accuracy goes up and down with respect to different kind of pre-processing steps using different algorithms, randomizing things. Okay, so if at all I give depth as quite more number. Okay, so instead of 3, I think 3 would be sufficient. If I give 6, so if you run that, you can see accuracy is like training accuracy is much more, and even test accuracy has gone up. Okay, so it is like 74 right now. Okay, but it will have its own kind of limitations where it has to um, it has to evaluate much more in results and all. Okay, so there are many aspects what we'll be getting. Okay, so that is about. Okay, so here I think my bad, I have not uploaded this MLP1. Okay, so that is not actually the result. Okay, so scaled is actually improving. Okay, so my bad, I have missed out that. Okay, so I was printing the previous results. So here you can see the results are much better when you do standard scalar. Okay, so normalization, especially in neural networks, will be a really helpful one to boost your accuracy much further. Okay, so that is about diabetes prediction. So basically here it is predicting whether it is high or not, whether the diabetes is there or not, and also we have certain level of certainties. Okay, so sklearn provides whole lot of features, whole lot of algorithms. So there are many pre-processing steps similar to uh, standard scalar. Okay, so you can actually use count vectorizer, all those things. Okay, so again it purely depends on data set how exactly. So work on more projects to have a better understanding. Okay, so that's all with respect to the diabetes prediction project.